Hi everyone, I'm Ben, and in this video I'm going to show you how to use R to do a very simple regression analysis. So by basic regression, I mean a linear model with two variables, one independent variable and one dependent variable. The data that we're going to be using in this example comes from the 2020 American National Election Study pilot data, and we'll be looking at two variables. One of them is age, and in this they just ask people their birth year and use their birth year to compute the age. And then the feeling thermometer score for Donald Trump. And so for that, they ask people to look at this thermometer graphic with 0 marked as very cold or unfavorable feeling, and 100 marked as very warm or favorable feeling. And they say, we'd like to get your feelings towards some people and groups who are in the news these days using something we call the feeling thermometer. Ratings between 50 degrees and 100 degrees mean that you feel favorable and warm toward the person or group. Ratings between 0 degrees and 50 degrees mean that you don't feel favorable and warm toward that person or group. You would rate them at 50 degree mark if you didn't feel particularly warm or cold toward them. If you come to a person or group that you don't recognize at all, you don't need to rate them. And then it asks about a bunch. You see here, Donald Trump, Barack Obama, Joe Biden, Elizabeth Warren, and there are a bunch more in this data set. We're just going to look at Donald Trump and see if age helps explain the variance in people's ratings of Donald Trump on this feeling thermometer. So if you if you run this names command, I imported the data set and named it anesP for anes pilot data. And if you run the names command, you'll see that they give you, they named these variables, where are the feeling thermometer ones? All the way up at the top. Here we go. FT, and so FT Trump 1 is what they named that Donald Trump feeling thermometer. And if you look at a table for it, anesP FT Trump 1, you'll see that 7 people have a 999. That's their missing value. And so I recoded those 7 people as missing, and also renamed the variable for the naming convention I am accustomed to for the feeling thermometer variables, which is Donald Trump feeling thermometer. And so if you look at my table, it's the same minus those 7 missing values at 999. And with ANES, you always need to make sure that you do that, or if it's any data that's not yours, or if it's your data and you don't remember what shape it's in, you always need to make sure you do that so that you're not modeling out of bounds numbers that are just markers for missing or non-response. Okay, then we can also describe, and I use the char function to describe to get the mean. So the average age is 42.4 with a standard deviation of 38. You can see there are 3,073 respondents here. We can also look at that variable with a histogram, anesP Donald Trump feeling thermometer. And you see, this variable, one could argue that a linear model is not best suited to this. There is an assumption that the outcome variable is normally distributed. And obviously, most people gave Trump a 0, and then you have a variety of responses elsewhere. And with feeling thermometers, that is fairly common. I would say this is a lot of zeros, even for the standards of politics today, but it would not surprise you to learn that some people have cold feelings about Donald Trump. So one could argue that a different form of regression would be appropriate, but for purposes of showing you how to use R to do a basic linear model, we're still going to use this outcome. Now, let's look at age. So we can describe anesP age. And the describe function is useful for a lot of reasons. So you'll see that we have 380 people here. So those 7 missing folks in the feeling thermometer score, we do have an age for them. When we run the model, it'll only include people who have answers to both variables. So it'll only be out of 3,073. you can see that the average age is 48.8. Did I say age up here? I might have said that the average age. If I did, what I meant to say is the average rating of Donald Trump on the feeling thermometer is 42. And the average age is 48. The standard deviation is 16.7. You can also see that the minimum age is 18 and the maximum age is 110. So there's one 110-year-old. And we can look at the table for the age variable to get a sense for, could not find function table. Maybe because that's not how you spell the word table. Okay, so yeah, you'll see there's one 110-year-old, one 92-year-old, two 90-year-olds, an 88-year-old. See, there are 29 18-year-olds. So yeah, you can just look at the table to see where folks are at. And of course, we can get a histogram for our age variable to get a sense for what that looks like. And you'll see, you know, most people are, it looks like, I don't know, between the ages of 40 and 60 or 30 and 60. So how do we do a regression analysis in R? Well, we're going to call this model 1. And then we make that little arrow. I'm told you can also just do an equal sign instead of that little arrow, but I grew up using that little arrow, so that's what I do. And then LM is the command to get a linear model. And this regression model is going to be a linear model, so we use LM. And then we do DTft, so that's Donald Trump feeling thermometer. That's the name of the variable in our data set. And then the little tilde, regress on. And then the independent variable is just age. So we have dt tilde age. We do need to tell it that our data set is called anesP. So this may be obvious, but I'm going to say it anyway. This is the name of the variable in the data set. It's actually the name of the variable that I gave it when I recoded it to get those 7 missing people out. And this is the name of the variable in the data set. So in your data, you'll use the variables that are the names of the variables in your data. They won't be, this is actually this is an arbitrary name that I've given the model. We could call it Ben, we could call it M1, we could call it Reg1. I'm going to call it Mod1. This is a regression command. So you'll always type LM or whatever kind of model you're using. This is a variable name from your data set. This is a variable name from your data set. Data equals is R language. And then this is the name of your data set. So I named this data set anesP because it's the ANES pilot data. So it's as simple as that. You run that command. Now notice when you run the command, it doesn't give you any output. It just ran this model and stored it in this object. So if you want to see an output, you have to do summary mod1 or whatever you named your model. If you named it Ben, then you would put summary Ben. And you see it gives you this nice output. It tells you, okay, this is the command that I just ran. So if I actually use a lot of the same model names. And so I have a lot of different mod 1s and M1s. And if I get an output that looks really funny, I'll be like, what's going on here? Oh, that's not the model I thought I was looking at. So it's just nice. It reminds you what you ran. Then it gives you your residuals. This is handy to look at. I guess I can talk a little bit about what this means when I show you the plot, but the minimum is a -55 and the maximum is 64, and then you get this range with the median residual. So that can be helpful to understand how well your data fits your model and how much you're missing your estimates by. Now, the intercept is interpreted as the value of y when x is 0. And in many cases, it's just a statistical artifact. So here, if x is 0, that means somebody's age is 0. And that's a possible age, but it's not a valid age in our data set. Remember, the youngest person in our data set is 18 years old. Nor is it a coherent age for the question we're asking, because somebody who's actually 0 doesn't have the language to express their evaluation of Donald Trump, nor do they have the cognitive function to form an evaluation of Donald Trump. So this value, 31.7, it doesn't mean babies would give Donald Trump on average a 31.7. It just means that for mathematical purposes, when age is 0, this is what the regression line would predict. And then this is the unstandardized regression coefficient. So that is interpreted to mean for every 1 year of age that increases, evaluation of Donald Trump goes up 0.2 of a point on that 101-point feeling thermometer scale. And here we have the standard error. And one thing you'll notice with anes data is that these tend to be pretty small because you get a really nice, precise estimate of effects when you have a sample size that large. And so, that's always handy. And when you have a really precise estimate, it's usually easy to say with relative confidence that the number is probably not 0. The null hypothesis is that this number would be 0. And so given the precision of our estimate, it's pretty easy to rule out the null hypothesis and say that there is a relationship between age and evaluation of Donald Trump. What is the nature of that relationship? How meaningful is that relationship? How important is that relationship? We'll have to do a little bit more work to understand that. And then this is the t-value used to generate the p-value. And notice it gives you e minus 0.7, indicating that you would take this decimal place and move it 7 spots over. So it would be 0.00000035 would be the p-value. Okay, so it also gives us the multiple r square and adjusted r square. So the adjusted r square is 0.008, meaning that age explains not quite 1% or 0.8% of variance in evaluations of Donald Trump. So that's our first clue that yes, we have a variable that has a statistically significant relationship with evaluations of Trump, but the effect is rather small. It's not even 1% of the variance in evaluations of Trump is explained by age. We can also, I think, make a few more, sort of use what we know about regression equations to illustrate the effect of age maybe a little bit more. So we could say, for example, for 20-year-olds, so we'll call this 20. So for 20-year-olds, it would be 31.68, which is the intercept, plus 20 years old times the slope or the coefficient, 0.2, we'll round up to 0.22. And if we run that and then say, okay, 20, run that, it's telling us that a 20-year-old would be estimated to score Trump 36.08 on the feeling thermometer. Now we can do this same thing. Let's do the same thing for a 40-year-old. So we would just replace this 20 with a 40, run it. So this tells us that a 40-year-old would be estimated to score Donald Trump a 40.48. So, about 4.5 points higher on the feeling thermometer scale. Now, what does 4 points mean on a 101-point scale? It's up to you, expert, to argue whether that's meaningful or not. Maybe I'm skeptical. Let's see what we would estimate for a 60-year-old. Of course, since this is a linear model, it's going to give us basically the same distance. Oops, what did I do wrong? I forgot to change that to 60. Okay. So then this is telling us that a 60-year-old would be estimated, our best guess is that a 60-year-old would score Donald Trump a 44.8 or almost a 45. So we go from 36 to about 45 when we go from 20 to 60, which means that on average, I would say that age doesn't have very much influence on how people evaluate Donald Trump. That's, it explains a very small amount of variance. And when you look at the nature of the effect, going 40 years in age, basically 2 full generations, you would only change your guess of somebody's evaluation of Donald Trump by, 8 or 9 points on that feeling thermometer scale. Now, a lot of times for regression, people like to graph it. And so I'm also going to show you how to generate some lines and look at your data a little bit. But I won't talk too much about why the code is what the code is. I will say that I'll take this syntax and paste it in the comments if you want to use it as a template to kind of adapt your own syntax. I'll also say with that, big warning, R does not like it when you copy and paste stuff from other programs, and so you'll probably want to manually type it rather than copy paste it, or even if you do copy paste it, manually type the command underneath what you pasted so that so that R doesn't get mad at you. Okay, so in base R, you just do with the name of your data set, plot, your X variable, your Y variable, and then you add abline, the name of your regression model. So if you run this actually without, here, I'll just take that off. If you run this without the abline, then it'll just plot your data set. So those are your various respondents here, and obviously it doesn't look great. If you add this plus sign, then it will give you that same plot, but it'll add the regression line. Here, I wonder if, that doesn't look great. Let me change this so that you can see the plot better. That's better, right? Okay, so if you run this, to go back, so if you run this with data set name, plot, independent variable, dependent variable, then it'll just give you this box with all of your cases in it as little dots. It doesn't look great. If you add your, if you add that plus and then you add abline and then the name of your regression model, then it'll put your line of best fit in there. And like I said, I don't think it looks great. So if you use ggplot, which is a package that you would need to install and load, so you can see I have ggplot2 loaded here, and you'd want ggplot2, then, there's a beautiful whole language to ggplot. And if you learn it, then you can do so many fantastic things. And what I'm going to show you here is just very basic, but the command is ggplot, data equals your data name, mapping equals AES, X equals your independent variable, Y equals your dependent variable, and then you add that plus line, geom smooth, and then in parentheses, method equals LM, and so this gives you your line of best fit from your linear model line on there. And then I like this geom jitter for situations where you have so many cases because I think it makes the dots look a little bit better. If you run that, you get this image, which I think looks a lot better than the base R. Still, you can see why the effect was pretty small. The blue line, the slope is pretty narrow. You can also see that the estimate is pretty precise, especially in the middle, because there's this gray shading that indicates the confidence interval. And you can see that it gets wider as we get further out, because here we're basing our estimate for 110-year-olds on not a lot of data. And you can see there are a whole bunch of people that gave Donald Trump a 100 on that feeling thermometer score up at the very top of this picture. And there are a whole lot of people that gave Donald Trump a 0 down at the bottom of this picture. And that those folks, pretty much go up and down the age range. So there were plenty of young people that gave Trump a 0. There were plenty of young people that gave Trump 100. There are plenty of old people that gave Trump a 0. There are plenty of old people that gave Trump a 100. Now, what else can you do in ggplot? Well, you can add labels for your X variable. So here the label is just age because that's the name of the variable. And you can add a y label. So in this, the y label is just DTft because that's the name of the dependent variable. But you can say, no, I want it to be feeling thermometer for Trump. You can also add a title for it. So, here we're calling it relationship between age and evaluation of Trump. And then there are various themes in ggplot, and I like the theme _BW. Maybe that's because these are my initials. Maybe that's because it's just a nice looking theme. And then of course I keep that geom jitter line. And so you see if you just add those couple of options, then you see the theme changes the way the text and the figure looks a little bit. We can kind of toggle back and forth between that and that. And you see we get the title of our plot, relationship between age and evaluation of Trump. Our X label is age in years, and our Y label is feeling thermometer for Trump. And so that's a little bit better looking plot. And again, I'll pop this syntax in the comments. And again, don't just copy and paste from the comments because R hates it when you paste from other programs. But you can copy and paste from the comments, and then I would manually type it before you run it. So hopefully that was helpful. That was a very simple regression model, but hopefully I showed you some useful ways to think about it, to interpret it, and to visualize it. In another video, I'll show you some other stuff, how to test the assumptions of regression, how to do multiple regression with multiple variables, yeah, how to do dummy coding how to dummy code some variables and how to interpret that, how to do interaction analysis, how to do mediation analysis. So there should be some really cool videos in the regression series. Thanks for watching to the end of the video.